Welcome in the chemistry education video lecture series. In this video, we observe the volumetric analysis. It is a quantitative analysis in which the precipitation titration. The precipitation titration, it is a titration where the precipitate is formed, and after completion of the precipitate, we get the change in color. That is the end point of the titration. In this topic, we will see the precipitation reaction, determination of the end point with the help of the precipitation indicator, Mohr's method, Volard's method, Fajan's method for determination of the halogen in the solution. In the first precipitation reaction, the precipitation reaction means any one of the component, for example, maybe a metal, and the anions present in the solution like halogen anions, they are determined when they interact with the metal like silver ions and get precipitate out. After completion of the precipitation, the indicator forms the complex with the silver metal and to form gives the color. That is the end point of the titration. Now this type of titration, it involves the formation of precipitate during the titration. The titrant react with analyte and forms an insoluble substances. The titration is continued till the last drop of the analyte is consumed. When the titrant is excess, it interact with the indicator to give the change in color. That is the end point of the titration. Now there are three methods we can use for the precipitation titration: Mohr's method, Volard's method, and Fajan's method. Now in Mohr's method, the chromate ion like potassium chromate, it shows a yellow color solution which is used as an indicator for this titration, and it shows the change in color as a yellow to red color. That is the end point of the titration. Now see in the flask, suppose these are the halogen ions, chloride ions are present. Now this chromate ion, when you enter into the chrome solution, we get the formation of the yellow colored solution. Now this yellow colored solution because of the chromate ion present in the solution. Now in Mohr's method, what happened? The silver chromate just starts the precipitate when we are adding the silver from the burette and it enters into the solution. It forms the silver chloride first, and after completion of the silver chloride formation, the silver forms the complex with the chromate ion, and then it gives converted into the red color solution. Now here the reaction is silver chromide. It gives the silver ions and chromate ions are present and it shows the red color. Now the KSP for the silver chromate is, we are finding out, we know the KSP of this 1.1 into 10 raised to minus 12, and the chromate ion concentration is 10 raised to 1.1 into 10 raised to minus 2 or 0.011 molar. If the concentration of chromate ion is larger than this value, then the precipitate of silver chromate is formed and we get the formation of red colored solution. Now initially what happened? The chloride ions and chromate ions are present here, and when we are adding the silver, it goes towards the formation of the silver chloride as a precipitate, white colored precipitate in the solution. Whatever the number of chlorine ion or bromine ion, iodine ion present in the solution, it forms the white colored precipitate, and after completion of the precipitation, then the next drop of the silver ion forms the complex with the chromate ion. And when the chromate ion is formed after completion of the silver chloride or even that silver bromide, silver iodide, then we form this solution and it forms the complex with the chromate ion. Silver forms the complex with the chromate ion, and after completion of this, the color of the solution get changed from yellow to red color. Now this is the end point of the titration, and from that one can find out how many molecules of the chloride ion or bromide ion or iodide ion present in the solution. That can be find out with the help of how much silver get consumed here up to the end point of the titration. And another method, that is Volard's method. This method is also useful for the chlorides and bromides present in the solution. Now in this method, excess silver nitrate is added to the precipitate, and an excess silver ion is determined by the back titration with standard potassium thiocyanate solution. Now in this titration, this is the type of the back titration, means maximum amount of the silver nitrate is added, and silver ion, get excess silver ion combined with the whatever the amount of anions are there, halogens are present in the solution, it gives the formation of precipitate. But remaining silver ions further treated with the thiocyanate ion to give the formation of silver thiocyanate. And this silver thiocyanate, whatever the thiocyanate we are adding from the burette, the next drop of the silver thiocyanate, potassium thiocyanate, get titrated with the indicator like the Fe3 plus, that is the ferric alum we have to add as an indicator, and this indicator shows the change in color as a red color, pink color. Now see the titration. Now for Volhard titration we require the X solutions, that is the halogen solution, silver nitrate solution, potassium thiocyanate, and ferric alum as an indicator. Now initially what happened, the solution containing the halogen ions are present in the solution. Now then it allowed to interact with the silver ion. We have to add the excess silver ion, and then it gives the formation of precipitate of the silver halide. It may be silver chloride, silver bromide, precipitate is formed. And then we are adding the more silver ions from the solution, and the remaining silver ion then further titrated. Now here the precipitate of the silver halides are formed, and we are adding the ferric alum, that is in the Fe3 plus ion. This we have to add into the solution. Then we have to add this potassium cyanide solution drop by drop from the burette, and when it interact with the treated with the solution, then it form the complex with the silver ion. Whatever the silver ions, excess silver ions are present in the solution, that is the remaining silver ion, it interact with the thiocyanate solution to give the formation of silver thiocyanate complex. Now this complete consumption of the silver thiocyanate complex, the next drop of the thiocyanate coming from the burette, it interact with the Fe3 plus, and it form the formation of the FeSCN2 plus complex, and it gives the formation of the pink color solution. Now this is the end point of the titration. From this end point of the titration, how much thiocyanate it is required for the titration, that can be find out, and from that we can calculate the how much silver ion they are excess, that is a back titrated, which is a added excess with react with the silver halide complex. Now in this way the back titrated, how much the silver ion get consumed, that can be find out. From that we can find out what is the amount of halogen present in the solution. This is the Volard's method. Third method is also used as a Fajan's method. Now this method is also used for the chlorides and bromides. For iodides this method is not used. Now in this method what happened, we require the halogen solution, silver nitrate solution, and indicator. Now indicator may be a fluorescein, may be a bromocresol green, may be eosine, methyl violet, or rhodamine 6G. Now according to the different pH, we can use these indicators. Now fluorescein indicator we can use at the slightly basic, that is 6 to 7 pH. 6 to 8 pH. Bromocresol green, it is used for as an acidic medium, that is up to the 5 pH, and eosine, methyl violet, and rhodamine, they are used in the acidic, it may be at the below 3 pH. Now in this titration what happened, the halogen ions are present in the solution, and these halogen ions when interact with the silver ion, it forms the precipitate, and formation of the precipitate is there. Now this precipitate, silver chloride precipitate is formed, but around that the chlorine ions get interacted, that is it forms the adsorb on the silver chloride precipitate. Now the sodium is present in the solution, or any another cation which is connected to the halogen initially, it forms the third layer. This is the adsorption type of titration. Now when the silver ion is gone adding the continuous adding whatever the chloride ions are present in the solution, they are form the precipitate, and after completion of the precipitation complete, at this stage what happened, the chlorine ions are less than the silver ion, and therefore it formed the complex, the precipitate of silver ion, and the chloride ion, whatever the chloride ions present in the solution, they form adsorb on the precipitate. But when we are adding the silver ion from the burette, it forms the silver chloride precipitate, and after certain point what happened, when chloride ion and silver ions are equally, then what happened, the silver, whatever the next silver ions are there, these silver ions are adsorbed on the silver chloride or silver bromide precipitate, and this silver ion forms the complex with the indicator instead of the positive ion sodium or any another potassium. So salt is there. Now indicator forms the complex third layer, and it gives the formation of the color, that is a colorless to the pink color. Now this is the end point of the titration. Now in this way the Fajan's method is used. Now for iodide, this method is not that much useful for the for chloride ions, we are using the Mohr's method, Volhard's method, then Fajan's method. For bromine, it is preferable for a Mohr's method and Volhard's method, and for Fajan's method, it is used for the iodine preparation. Now in this titration, precipitation titration, we discuss on the precipitation reaction, the end point of the titration, Mohr's method, Volhard's method, Fajan's method for the determination of hydrogen from the solution.